Okay, so what I've written up on the board here for this example is two separate problems, and we want to compare these similar looking problems. So in part A, we are asked to solve sine of theta equals -1/2 on the interval from 0 to 2 pi. And in the second problem over here, we're asked to evaluate arc sine or inverse sine of -1/2. Now, what makes these two similar is that in both problems, where we're asked to solve sine of theta equals -1/2, and when we're asked to evaluate arc sine of -1/2, in both of these examples, our output, our answers, are going to be an angle. So we're looking for a theta, or an angle, in both of these problems. Okay. But yet it turns out that our answers for these two problems are going to be very different. And the reason for that difference has to do with the subtleties of what is being asked and the subtleties of the inverse trig functions. So let's start with the solve sine of theta equals -1/2 on the interval from 0 to 2 pi. Okay, so I look at this equation, and I have sine of theta is equal to -1/2. All right, so I notice that this -1/2 is negative, and when I think about the sine function, sine is negative in the quadrants where y is negative, because sine is y over r. So sine is negative in quadrant 3 and in quadrant 4. So positive in quadrants 1 and 2, negative in quadrants 3 and 4. So we are looking for angles of theta that reside in the interval from 0 to 2 pi. So starting an angle of 0, swinging up and around clockwise one time around the circle. Counterclockwise. Yes, this is counterclockwise, one time around the circle. Okay, so I know that my answer is going to involve an angle in quadrant 3 and an angle in quadrant 4. Those are the two quadrants where sine is negative. Okay, so I'm going to draw my reference triangles. And thinking about sine of theta equals -1/2, sine is opposite over hypotenuse, or y over r. So that means that the y value on these triangles will be -1, and the r value will be 2. And as soon as I see those two sides on one of these triangles, the 1 and the 2, I know that the third side is square root of 3. And I also know that my reference angle is the angle across from the 1, so the smallest side. So this is a reference angle of 30 degrees or pi over 6 radians. And same for the other angle. Our reference angle is pi over 6. Okay, so now the question is, what are these two angles when we start in standard position from the positive x-axis and swing over to quadrant 3, and when we start at the positive x-axis and swing into quadrant 4? Okay. Now, since I know that these are 30-degree angles, I can think of my two theta values as 30 degrees past 180, so we have 210 degrees, and 30 degrees less than 360 is 330 degrees. So I can think about these in terms of degrees. My final answer must be in terms of radians, so I would need to convert these into radians. So 210 is 7 30-degree measurements. So that's 7 times pi over 6. And 330 is 11 30-degree measurements, so that's 11 pi over 6. So my two answers here are 7 pi over 6 and 11 pi over 6. Now, I could also figure out these measurements by counting blocks of pi over 6, and there would be 6 of them across the top plus one more. And then I would have, if I counted all the way around, 6, 7, 8, 9, 10, and 11, and there would be 11 blocks of pi over 6 if I thought about it that way. Okay, so that's our part A. Okay, so now we're going to look at the second part of this example, where we're going to evaluate arc sine or inverse sine of -1/2. Okay, so when I'm thinking about the inverse sine function, my input is a ratio of sides. And in this case, because this is arc sine, the ratio of sides is opposite over hypotenuse, or y over r. And the output that we want, the thing that we're going to put inside the box, is going to be an angle. And when I think about the arc sine function, the range for arc sine or inverse sine of x is negative pi over 2 up to pi over 2. So when I think about angles along the unit circle, or just angles in the xy plane, an angle of negative pi over 2 is, I want to think about clockwise 90 degrees, so pointing directly down from negative pi over 2 up to 0, and then angles swinging up to an angle of positive pi over 2. So I want to choose angles that are going to be an angle in quadrant 1 or quadrant 4. And since our ratio is negative, quadrant 1 sine is positive, and quadrant 4 sine is negative, so I'm going to choose an angle in quadrant 4. Okay, so let's draw that angle. Here it is. I don't really know what it looks like, so I just drew an angle. And now I'm going to create my reference triangle. And let's see, so our ratio is negative 1/2. And that is, because this is arc sine, that is the ratio of opposite over hypotenuse, or y over r. So our y value is negative 1. I know the negative goes with the y because the r value is always positive. Our r value is 2. And when I look at that triangle, it's certainly not to scale, but I recognize the side lengths of 1, 2, and square root of 3. And so my reference angle in here is 30 degrees, or pi over 6 radians. Okay. Now, we're not quite done with this problem yet, but let's look back over here at the previous example. Over here, we had two possible answers. Okay? One was in quadrant 3 and one is in quadrant 4. Okay? Now, because we're talking about arc sine or inverse sine, we are only looking at angles from quadrant 4 and quadrant 1. Okay, so that automatically removes this guy over here in quadrant 3. So that's one difference that's happening. Another difference is this angle that's in quadrant 4, in our first example of sine of theta equals negative pi over 2, the way that we measured this angle is that we measured this angle in a counterclockwise direction. And so we ended up with an angle of 11 pi over 6. When we're talking about the inverse sine function, we are talking about angles that are measured, you can think of it from an angle of 0 clockwise down to negative pi over 2, and from an angle of 0 counterclockwise up to an angle of positive pi over 2. So this angle in here, the way that we measure it when we're talking about the inverse sine function, is that we are going to measure this angle in a clockwise direction. And when we measure the angle in the clockwise direction, that means that our angle will be negative, and we are opening up this angle to an angle of pi over 6. So the angle that we are looking for in this particular example is that inverse sine of negative 1/2 is going to be negative pi over 6. Okay. So yes, we had the same terminal side as we had over in our first example, but the angle measurements that we actually come up with, over here we had a measurement of 11 pi over 6. We measured in the counterclockwise direction, whereas with arc sine, we measure in the clockwise direction, so we drop down clockwise pi over 6 radians. Because it's clockwise, we have a negative value there. So negative pi over 6 and 11 pi over 6 are not equal angles, but they are coterminal. Okay? All right, so take a minute and think about why these guys are different. If you're not sure, shoot me an email and ask again. All right, so these next two examples are to talk about this warning up here. And the warning says, because of restricted domains and ranges, these inverse trig functions do not always undo the function or undo the original function the way we might expect. And so when I talk about the restricted domains / ranges, what I'm talking about is our restricted domains on the original functions, which correspond to very special ranges and very special choices we have to make for the angles when we're talking about the inverse trig functions. Okay, so I have two examples up here. One is inverse cosine of pi over 3. And over here I have inverse cosine of 4 pi over 3. And in both examples, we would expect that our answer, because we have our inverse trig function and then the original function, those should undo each other and give us back whatever we started with, which is, in this case, pi over 3. So let's see if that's the case. We're going to check it out on the graphing calculator. Okay, so on the graphing calculator, I'm going to type in the first one, which is inverse cosine of pi over 3. So the way that I do that is I'm going to look for the inverse cosine function. So I have second cosine, so that's inverse cosine of pi over 3. And I hit enter. And I was expecting to get pi over 3. I got a decimal value because that's what calculators do. So let's compare that to pi over 3. So pi over 3. Yep, those match. So the inverse cosine canceled the cosine or undid the cosine function and left us with pi over 3. Cool. Let's do the same thing with our second example, where we have inverse cosine of 4 pi over 3. And I hit enter, and I get some decimal approximation. Okay, well, let's see. That should be 4 pi over 3, so let's see what happens. So 4 pi over 3. Oh, this doesn't quite match up. So in this example, when we started with 4 pi over 3 and we applied the cosine function and then undid the cosine function, we didn't get back what we started with. So let's see why that's happening. So let's start with our example A here, where we have inverse cosine of pi over 3. So I'm going to start with the stuff inside the parentheses, and I want to start by evaluating cosine of pi over 3. So when I think about cosine of pi over 3 is 60 degrees. So, you might think about that angle in a lot of different ways, but you may already know, oh, I have the unit circle memorized, and so I know what cosine of pi over 3 is. But in case you don't, or if you like to build it the way I do, I'll draw my picture. Here is an angle of pi over 3, or 60 degrees. And if I have a 30-60 right triangle, then my sides are 1, square root of 3, and 2, with the square root of 3 being opposite of the 60 degrees. So cosine is adjacent over hypotenuse. So cosine of theta is adjacent over hypotenuse, or x over r. So for us, cosine of pi over 3 is, cosine of 60 is x, 1 over 2. Okay, cool. So this thing inside the parentheses is equal to 1/2. So we can rewrite this as, now we want to evaluate the inverse cosine of 1/2. So to evaluate inverse cosine, the first thing I tell myself is, okay, the thing inside the parentheses needs to be a ratio of sides, which it is, and my output is going to be an angle. So I have a ratio of sides inside the parentheses, and my output will be an angle. Now, when it comes to the inverse cosine function, that's this guy down here, my range is 0 to pi. So I'm looking for an angle where the angle is somewhere between 0 and pi, because that's my range. Okay, so an angle between 0 and pi, here's a measurement of 0. I can swing from 0 over to an angle of pi. So I can choose an angle anywhere on the top half of the circle. Now, in this case, our ratio is positive, and cosine is positive in the first quadrant. So I know that my picture is going to have an angle in the first quadrant. Okay, so where were we? We were drawing an angle here, and the angle is in quadrant 1 because inverse cosine has choices from quadrant 1 and quadrant 2, and quadrant 1 is where cosine is positive. Okay, now our ratio is 1/2, so we're thinking about 1/2 is adjacent over hypotenuse. So our adjacent side is 1 and our hypotenuse is 2, and I recognize that triangle as 1, 2, square root of 3, and our angle here is an angle of 60 degrees or pi over 3. So the angle that we're going to choose is an angle of pi over 3. So our final answer here is that inverse cosine of cosine of pi over 3 is pi over 3. Okay. We like chalk. Okay, so let's take a look at part B. In part B, we have inverse cosine of 4 pi. And in this one, what we saw was that our final answer is not going to be 4 pi over 3. So I look at this expression up here and I say, okay, what is cosine of 4 pi over 3? And I think about 4 pi over 3, and 4 pi over 3 is, well, you can handle this. We can do this together. You can do it. Yes, you can. Yes, you can. 4 pi over 3 is 4 times pi over 3, so that's 460 degrees, which is 240 degrees. Okay, so I can draw that angle. That is 60 degrees past 180. There it is. We have a reference triangle. We have a 60-degree angle. So let's see, my sides are going to be negative square root of 3, negative 1, and positive 2. So cosine of 4 pi over 3 is going to be the adjacent side over the hypotenuse, which is negative 1 over 2. Okay, so that's fine. So now that means that cosine of 4 pi over 3 is negative 1/2. So we want to evaluate inverse cosine of negative 1/2. All right. So I look at my ratio. I have a ratio, and my output is going to be an angle. And my ratio is negative, so that means that in terms of inverse cosine, I'm looking at quadrants 1 and 2, and cosine is negative in quadrant 2, so my angle is going to be an angle in quadrant 2. I can already see that my angle will be different than what I expected. Okay, I draw my triangle. My ratio is negative 1 over 2. So that is adjacent, which is negative 1, over hypotenuse, which is 2. I recognize the third side, that's square root of 3. And my reference angle is 60 degrees, or pi over 3. So my angle now is an angle that's 60 degrees short of 180. So this angle is 120 degrees. or 2 pi over 3 radians. Okay, so what that tells me is that inverse cosine of 4 pi over 3 is equal to 2 pi over 3, which is not the same as what we started with. But what you'll notice is that cosine of 2 pi over 3 and cosine of 4 pi over 3 gave you the same answer. But what we need as our final answer is an angle that lives in either quadrant 1 or quadrant 2, an angle that's part of our range of our inverse cosine function. Okay, thanks.